Exponential and logarithmic functions. What about that? Well, obviously both are functions, and functions express relationships that can be either increasing or decreasing, which shows positive or negative relationships. We will first be focusing on the exponential functions. Exponential functions infinitely increase outwards on the x-axis, giving the domain for x a negative infinity to positive infinity on every exponential function. The range, however, does not increase infinitely. We can see population in this example increase exponentially. On year 1, we start out with 2 people. Year 2, we have 4 more people. 2 years later, year 4, we have a total of 16 more people. This is a great example of exponential because we can see it increasing exponentially over time. However, the population will never dip below 0, giving us our asymptote. And we'll talk about that later. Now, how do we graph these exponential functions? First, you get your exponential problem. For the first step, you want to make a table. Just plug in x values into your equation to get some outputs. Next, plot your points and sketch a small graph. Next, you want to find the location of your asymptote. This will be the point where the y never decreases into. It'll get very close to the line, but it will never cross it. In our case, the answer is y equals 2. Our next step, step 4, is to find out if it's growing or decaying, increasing or decreasing. In this case, we can see we're getting a positive output in not only our table, but in our graph itself. Therefore, it is a growth. Our last 2 steps will be finding the domain and range. In step 5, we will define the domain first. As we discussed earlier, every domain in an exponential equation is negative infinity to positive infinity, because it's always increasing outward both positively and negatively. Our final step is to find the range. The range is limited as we talked earlier. It is from the asymptote up or from down to the asymptote. So in our case, it is 2 to infinity. To solve exponential equations algebraically, all you have to do is set the bases to each other and then cross them out and have your answer. After you do this, the equation gets very, very simple. You can see how now it's just 2x minus 1 equals x plus 3, and that's a very easy problem. As you see, we get x equals 4. So what if the bases are not the same? We can see that in this problem. What we have to do is make them the same. So what we do is we take 9 and make it have a base of 3. The easiest way to see this is 3 squared equals 9. So we set up the problem again, and then we do the same exact thing. Cross out the 3's, and then we just set up the problem. 2x minus 1 equals 2. Now, once again, this is a very easy solve. We eventually get the answer, x equals 3/2. Now on to logarithmic. Logarithmic is just the inverse of exponential equations. Then the inverse of something is basically the opposite. You can see that here we have 3/2 is this inverse of 2/3, and vice versa. Like exponential equations, we're going to start by graphing logarithmic functions. And here's how we do it. We're going to start the same way we did with exponential and make a table. Logarithms, however, are much harder to do in your head. So we're going to take our table and we're going to just plug it into a calculator to give us all of our outputs. And where we see an undefined come out, that will be our asymptote. And because logarithmic functions are inverse of exponential, instead of having an infinite domain, we will now have an infinite range. But next, we're going to graph and plot. This is just done by the same way, just a normal graphing and plotting, but remember that it will never touch the asymptote line, so y will always be infinite in logarithmic, and x will not. So we see that our asymptote never gets touched, but we can see it increasing in both up and down. That gives us our domain and ranges. Of range is infinity to infinity, and domain is -2 to infinity. Next, we're once again going to determine if it's increasing or decreasing. We can see that this equation is also increasing because of its positive outcomes. So we write down increasing, and we move on to our next step, which is our asymptote. Because our asymptote is on x instead of y, the answer will be x equals -2 instead of y equals -2. Finally, we are just going to be writing down our domain and ranges once again, and we have already done that, but we might as well do it again. So our domain is -2 to infinity, and our range is infinity to infinity. When solving algebraically, however, it might be easier to do by hand if you do not have a calculator. The easiest way to do this is to convert from logarithmic to an exponential function. To do this, all you need to identify are the bases, the exponents, and the answers. And then you can just flip around an equation and make it a very simple exponential equation and just solve it by that. So we're first going to practice converting. My favorite way to do this is just switch around the numbers, and I did make a goof here. It's supposed to be a 3 instead of a 4, but I'll change that in a second. But yeah, you just take the exponent and the answer, and you just switch them around, and that gives you your answer. You can also convert from the other way just by using the same simple principles of keeping the bases, the exponents, and the answers in the correct places. In addition to this, even if you have a calculator, you can check your work just to make sure you're correct. To solve problems, all you have to do is just step 1, convert. So you'll take this, so it'll become 2 to the 4th power equals x, and then you just solve it like you would any other equation. In this case, 2 to the 4th power is just a number, so you just multiply it by itself, and then you realize x equals 16. However, if you don't get something like 2 to the 4th power equals x, you can just do the same steps as you do with the exponential equations. So then now you just follow the steps of the exponential equations, so you match the bases, so that becomes 8 squared, and then you cross out the 8s, and then you just solve the equation, and bam, shabam, schmackle, bam. I see you being a math genius.